Hello everyone, my name is Syed Islam. In this video, I'm going to talk about membrane-assisted liquid extraction for 2,3-butanediol recovery from fermentation broth. What is 2,3-butanediol? 2,3-butanediol is a chemical precursor or chemicals that is used to produce various chemicals and also as a sustainable aviation fuel. So 2,3-butanediol, also called BDO, which is produced or which can be produced from fermentation broth, for example, from biomass conversion process, corn stover. However, when BDO is produced from fermentation broth, it is produced mostly in dilute concentration and so mostly in water. So this BDO has to be recovered from the fermentation broth, and to for the recovery of BDO from water or fermentation broth, one of the approaches is called liquid extraction. In liquid extraction, a solvent or organic solvent is used that has high affinity for the BDO, but it has the lowest affinity for the water, so it can be extracted. However, the challenge is with liquid extraction is it forms emulsion and the scaling in a large scale or industrial deployment. To address these challenges, membrane assisted liquid extraction could be a potential pathway. So the way in membrane assisted liquid extraction works, let's say the hollow fiber. So this is a hollow fiber membrane. It is porous, and through the tube side or lumen side or board side, the a solvent such as hexanol pass through it. The solvent is hydrophobic and the membranes is hydrophobic, so the ex the solvent can penetrate through the pores to the other, and then the other side, the BDO containing fermentation broth, which is mostly aqueous, pass through it. But because it is hydrophilic, it doesn't get through the pores. So these two phases remain separated, but the hexanol come in contact with the BDO and it extract the BDO. And so once it comes out the module, and these this BDO can be separated from the fermentation broth by evaporation, or wiping evaporation or distillation, and BDO can be recycled back to the membrane. uh, that it can produce very high purity BDO because hexanol or the organic solvent has least affinity towards the water, but it has high affinity for the BDO. So, and also this process provides very high surface area, these membranes. So these two phases come in contact, in very close contact. So this is a very energy efficient and effective approaches, and it works as a single step. It continuously works. So it provides various advantages compared to conventional. For example, it provides high surface area for contacting the two phases. It's a continuous single step process, and it's also modular, which means the scalability is a big advantages. You have high demand, you add more modules. You have low demand, you add lower number of modules. So it's pretty linear scale up, and the whole process is works at atmospheric conditions, so no temperature, no pressure. The separation happens due to chemical affinity, so it's requires low energy, low capital and operating cost, and most importantly, it prevents the emulsion formation. So if these two phases are mixed together in liquid extraction, it forms an emulsion, and it's difficult to break that emulsion. But in membrane assisted liquid extraction, these two phases are not mixed together like a mixer and settler. So as a result, it just at the interface the separation happens, so it prevents the emulsion formation, which is a big advantages using membrane and the scalability. So overall, the membrane assisted liquid extraction is a much better approach, or a more advanced approach compared to uh, liquid extraction, especially for BDO separation or recovery from fermentation broth. Thank you for watching this video. I hope you enjoy.